As we're coming back from our Thanksgiving break, we need to review chemical nomenclature and chemical formula writing. And so why do we do that? Why is it important? Well, since we're coming off a holiday where we typically have a lot of food around, I just wanted to show you some labels. And if you are in honors, you're going to be doing a project where you're going to be looking at labels like this quite a bit. But it's good to be familiar with some of the chemicals that are in your ingredients list in your food, because when you look at an ingredients list, you don't want to be so scared by this seemingly foreign language that you don't actually decide whether or not it's something you want to eat. So we need to be familiar enough with a lot of these compounds so that when you look at the label, you can make wise decisions as a consumer whether or not you want to use these products. For example, I always think it's interesting what we can find. Sodium lauryl sulfate, it says here, is a whipping agent that probably makes this angel food light and fluffy, but it's also the second most abundant thing in shampoo. So something to think about, something to consider if you're going to go for a second or third helping of the cake. So just to be a wise consumer about your choices. So these are two different compounds that we're studying. There are the two main compounds that exist are covalent bonds and ionic bonds. So go ahead and take a moment, pause the video, uh, write this table in, and write down the characteristics of covalent bonds and ionic bonds. We are going to be doing a lab that will investigate these properties, but this is something that you need to kind of have in the back of your head as we go through them. They are completely different compounds. So go ahead and pause the video, copy that down. Okay, so because these are two totally separate species, these are two totally different animals, if you will, covalent and ionic bonds. Um, Part of that has to do with on the molecular level. If we look at covalent compounds, remember that covalent compounds share that outer energy level of electrons. So it's kind of like they're holding hands. And as two people who hold hands, they can walk closer to each other or they can walk a little farther apart while still sharing that bond. And that's what allows covalent bonds to be squishier and softer. Those compounds tend to be soft solids or liquids or even gases at room temperature. Whereas ionic compounds are the opposite. They are very rigid because they are individual ions that do not share. They're attracted to each other because of their opposite charges, negative and positive attract. And so we'll have a positive ion that attracts negatives all around it, a negative ion that attracts positives all around it. And you see that pattern will continue over and over and over again. And so that's why it doesn't matter how many ions are there when we name them. We're really just naming the ions that are there because it's going to be a repeating pattern over and over and over again. And so that's one of the reasons why we treat these differently. They are different compounds, so we're going to name them and write their formulas differently. So to name these ionic compounds, first we have to figure out, is it an ionic compound or a covalent compound? Because they're different, so they do have different rules for naming. And so the first thing you should always do is look at that first element and see if it's a metal or a nonmetal. And if it is a metal, then congratulations, it's an ionic compound. And so you can just name the ions. First name, last name. First ion is always going to be the cation. Second one is always going to be the anion. If it's a metal from group 1, 2, or 3A, where aluminum is, or silver, then they're always going to have the same charge. So you don't have to say what the charge is, you just name what that metal is and then name the nonmetal ion. That's it. However, if it's not, if it is one of these elements on the periodic table that's in the B group, the D block, the ones that have transitional charges, then we're going to have to use Roman numerals to say what that charge is, because it could be different for each of these in the transition metal group for the most part. So we have to use Roman numerals in that case. If they're nonmetals, which is our next part here, and remember that nonmetals are to the left of this, or to the right of the stair step. These are all nonmetals. Well, then you know that you're going to use prefixes to name it. Prefix, first nonmetal, prefix, second nonmetal, and that's it. That's how you name it. So go ahead and take a few minutes. I have some examples for you here. And I'd like for you to go ahead and name them. And I have this little helpful table for you. But remember that if the anion, if the second part of this compound And remember, there's only a first and a second. It's like you have a first name and last name. Compounds will have a first name, last name. First part, second part. First part, second part. Just remember that the anion, that negative ion, if it's only one element, it's going to have an ide. If it has some oxygens in it, it's either going to be 8 or ite. The 8 always has one more oxygen than the ite does, and usually they all have the same charge, the monatomic ion and the polyatomic ion, so that's awesome. That helps you memorize them. So take a moment, pause the video, and write down your answers for these ionic compounds. Okay, we're ready to check now. Let's remove our cover here for our answers. And just get that one. There we go. So these are the answers that we should have. Remember that we're just naming the ions. These are metals. I could tell by where they are in the periodic table. So I'm just naming the first thing and then the last thing. It doesn't matter how many are there. This is sodium sulfide. This is barium chloride. This is aluminum because I memorized that Al is the symbol for aluminum, which means that everything else, no matter how many atoms are there, happen to be the phosphate. Here is our next set of practice review problems. These are going to be covalent. Let's see if you can go through what we always do first is look for a metal first. Remember that we've got a first part and a second part to each of these compounds. So try and use this flowchart. Use the periodic table. Pause the video, work these out, and then we'll go over the answers. So pause the video. Usually the trick on answering these is to make sure that you don't use ionic bonding rules if they are covalent compounds. And so if we go ahead and remove these, this is disulfur tetraiodide, silicon dioxide. We don't write mono if it's the first element that we only have one of. And on this one was probably a little tricky. So again, you've got to remember what your polyatomic ions are. Yes, this is a nonmetal, but if you look at it and you try to name the first thing and then the last thing, this is not one of your polyatomic ions. So that tells you right away that the polyatomic ion has got to be the first thing, which is NH4. And so when you look that up on your tables, that is ammonium chloride. Okay, so now on to the next one. We're going to have some mixed practice. Okay, try this mixed batch of compounds right here. Pause the video, write these down, work them out, and then check your answer. So go ahead and pause the video and work them out right now. Here are the answers. Hopefully you got really close to them if you didn't get exactly right. Remember that all of these are going to have a first name, last name. First element here is K. That is a metal because it's to the left of the stair step. So I know that I'm just going to name the ions. It doesn't matter how many are there. K is potassium. SO4 is not sulfur, but sulfate. This is a non-metal because phosphorus is here to the right of the stair step, so I use prefixes. Same thing with sulfur. Non-metal, so I use prefixes. Lithium is a metal, so I use ionic compound naming rules. So I just name the ions. It does not matter how many are there. I don't need to use prefixes. Aluminum, again, we're going to consider aluminum a metal. It is to the left of the stair step, so it is a metal. We just name the ions. It does not matter how many are there. Aluminum sulfide. I'm going to move fairly quickly through the review for formula writing on ionic formulas. If you need some more time to go through this slower, go back and watch the crisscross video notes that we took the first time. That will be helpful for you. So I'm going to start off with sodium and sulfide. Sodium is in group 1A. That's where we get our charge from, and we've got our charge for sulfide there. Remember that these are just first name and last name problems. If you could figure out what the first part is, the rest is the second part, and then you just put them together in such a way that the charges will neutralize each other. If they don't equal 0, whichever you have more of, positive or negative, they're going to keep attracting the opposite charge to them until they've been neutralized. And so the easy way that we figured out how those numbers would come together is by using a crisscross method, which, if we look at the answer for the first one, gives us Na2S for sodium sulfide. Looking at the next one, magnesium oxide, looking at the ionic charges, it's a +2, -2. those do automatically cancel each other out and make a neutral compound. So the answer to that is just MgO. Trilithium nitride, pause the video. I'm going to give you the answer here in a second. Did you figure it out? All right, here it is, lithium nitride. Moving on to polyatomic ions, ammonium sulfide is our first example, and ammonium is a polyatomic ion. It does have a charge. Remember, that charge is for the whole group of atoms, not just for the hydrogen, but for the whole group. And so when we put these together and use our crisscross method, we'll have one sulfide and we'll have two of the whole group, not 42 hydrogen, not 2 times 4 hydrogen, but two of the whole group. So when we look at our formula, it's NH4 parentheses 2 sulfide. Similarly, when we look at calcium hydroxide, that -1 charge on hydroxide is for the whole group of atoms in that polyatomic ion. The parentheses I find help me separate the charge and the number so that it looks like it's going to the whole group. So continue that. That is probably going to be helpful for you. So when we use those same rules, we see that calcium hydroxide is CaOH2. Go ahead and pause the video, try barium sulfate, and then check. I'm about to show you the answer, so I hope you did it. Your answer should be BaSO4. Those charges cancel each other out. On to transition. Remember that the Roman numeral tells you the charge of the metal because you can't tell by where they are on the periodic table what they are. So iron 3 sulfate is made up of iron 3 ions and sulfate ions. When we put those two together by crisscross method, we're going to need 3 sulfate, but not 43 oxygen. We need 3 sulfates and 2 irons. So our answer ends up looking like that. When we look at cobalt 1 sulfide, cobalt 1 is our charge right here, +1. Sulfide is -2. Those are monatomic ions, so those are a little bit easier. Just go and use your crisscross, and when you do, you should get CO2S. Okay, because we had 1 sulfide that was needed and 2 cobalt that were needed in order to balance out those charges. All right, go ahead and work out the next 2. Pause the video, next 3, and then we'll check the answer. Are you ready? I'm about to show you the answer. Okay, so cobalt 1 chloride should be this. Lead 4, this is lead 4 sulfide. Lead 4 sulfide is this. And zinc 2 carbonate is, let me get rid of that, is that right there. Writing the formulas for covalent compounds is probably the easiest thing that we could do. I'm just looking here at our prefixes. Di means 2. Sulfur, we have memorized, is just S, and so that means S2. Pent is 5, oxide is oxygen, so when we write that formula, it's just 2 sulfur, 5 oxygen. So let's see, disulfur, pentoxide. Disulfur, pentoxide. Go ahead and pause the video and do trinitrogen heptachloride and check your answer. Then do tetracarbon monosulfide and check your answer. Are you ready? I'm going to show you the answer. So there is trinitrogen heptachloride. Hepta is 7, hexa is 6, in case you got that confused. Tetracarbon monosulfide, are you ready for it? Here it is. There you go. Tetra means 4, carbon is C, nona is 9, and sulfide is the S. So that is your review. We're going to work on these a little bit more, and you're going to still work on these on your own as well. So we'll see you in class.